Hey everyone, thanks for tuning in. Today we're going to be looking at the answers to the 2020 Maths Advanced HSC, more specifically Booklet 1 of Section 2. So this is questions 11 through to 20. Now these questions aren't very difficult, these set of questions that I'll be completing. They're generally, they're going to be towards the beginning of the short answer section of the paper. And ideally, you want to try and maximize your marks in this section. So as we can see, it's out of 32 marks. Ideally, you want to try to, be getting around 25 and above. So let's begin. The first question, question 11, says there are two tanks on a property, tank A and tank B. Initially, tank A holds 1,000 liters of water and tank B is empty. Tank A begins to lose water at a constant rate of 20 liters per minute. The volume of water in tank A is multiplied by that equation, where V is the volume in liters and T is the time in minutes from when the tank begins to lose water. On the grid below, draw a graph of this model and label it as tank A. Okay, so what we notice is that this is the equation for tank A. Okay, and initially we start at 1,000 liters, so at T equals 0. Okay, at T equals 0. We're going to be at a volume of 1,000. Okay, and the question is, well, how are we going to draw this line? And what you can do is just pick on a point. Let's say, well, at what time is the volume 0, for instance? So we'll let V be equal to 0. So I'll just do it on the side here. So V is 1,000 minus 20t. We might set V equal to 0. And that's 1,000 minus 20t. And we'll bring the 20 over to the other side and divide through both sides by 20, which will give us t is equal to 50. So at t equals 50, we have a volume of 0, so this point here. And we know this is going to be a straight line, so we just have to draw a line which connects these 2 points. Like so. And last but not least, we just need to label this as tank A. So we might write to the side here, tank A. Okay, and that's it. There's our 1 mark. The second question says tank B remains empty until T equals 15. When water is added to it at a constant rate of 30 liters per minute, by drawing a line on the grid on the previous page or otherwise, find the value of T when the 2 tanks contain the same volume of water. So what we notice is T is equal to, up until T equals 15, we have an empty container, or in other words, the volume is 0. So if we look on here, all the way up until T is 15, our volume is going to rest at 0. And after T equals 15, we're going to increase by 30 liters every minute. So if you like to think about it, in 5 minutes, we increase by 30 lots of 5. So that's going to be 150. In 10 minutes, we increase by 10 lots of 30. So that's going to be 300. So from 15 to 25, for instance, we're going to go from 0 to 300. Okay? So we've got like this point here. And what we're going to do is just construct a line which goes through these 2 points. And we obtain this line over here. Okay, so we'll label this tank B. And then the question says, hence find the time where they have the same volume, and we can see that's when they intersect, and that's going to be at around t equals 29. So we say by observing the intersection of the 2 lines, they contain the same volume when t is equal to 29 minutes. Okay? And then the final question says, using the graphs drawn or otherwise, find the value of t, where t is greater than 0, when the total volume of water in the two tanks is 1,000 liters. So we want the total volume of water in these two tanks to add up to 1,000 when t is greater than 0. So obviously, at this point here, 0 plus 1,000, they have 1,000 in them, but we want t to be greater than 0. And there's no like real easy kind of way to do this, but hopefully what we can observe is that at this point, our volume is equal to 900, and that's in tank B, and in tank A, our volume is equal to 100. So at t equals 45, the total amount is 1,000. So at t equals 45 minutes. Okay. So that is question 11. Now we will move on to question 12, which says calculate the sum of the arithmetic series 4 plus 10 plus 16 all the way up to 1,354. So what we're going to have to do here, okay, is record the sum of an AP. Now that is going to rely on however many terms we have, and it's not very obvious right now how many terms we actually do have up to 1,354. So what we're going to do is use the basic, term formula for an AP, where t of n is equal to a plus n minus 1 times d. Now the term we're considering is going to be 1,354 because we want to know what term that is equal to a, which is 4, that's our first term, plus n minus 1, because we want to find n, lots of d, which is our difference, which is 6. Okay, if I subtract 4 on both sides, I get 1,350 equals, if I expand this, I get 6n minus 6. I add 6 to both sides, and I get 6n is 1356. And dividing by 6 by both sides, I get n is equal to 226. So we have 226 terms in this AP that we have to sum. So then I'd say the sum is equal to n on 2 outside of a plus l, where n is now 226 over 2 outside of a, which is our first term, which is 4, plus l, which is our last term, which is 1,354. And just by putting this in the calculator, we can obtain 153,454. Okay, so yeah, it should be relatively simple. So the next question is question 13, which is evaluate the integral from 0 to pi on 4 of sec squared x dx. Now this should be a very, very simple question, because we should know what sec squared, the integral of that is, and that is tan. So the integral from 0 to pi on 4 of sec squared x dx is equal to tan x from 0 to pi on 4, and that's equal to tan pi on 4 minus tan of 0. Okay, and now tan of pi on 4 is tan of 45, which is 1, minus tan of 0, which is 0, which is just 1. Okay, so now if we move on, we've got question 14, which says history and geography are two of the subjects students may decide to study. For a group of 40 students, okay, so total is 40 students, the following is known. 7 study neither history nor geography, 20 study history, 18 study geography. A student is chosen at random. By using a Venn diagram or otherwise, find the probability that a student studies both history and geography. So first thing we need to do is construct this Venn diagram. So we know that within this Venn diagram, there needs to be 40 students in total. And we've got a little bit more information saying 7 study neither, 20 study history, 18 study geography. So I'm going to do my little Venn diagram here. History and geography. Okay. Now I need this whole thing to be 40, so I got to consider, well, what do I know, like guaranteed? and it's that 7 study neither history nor geography. So 7 is on this outside here, which leaves, if there's 40 students in total, that means there's 34 students which needs to be here. Now we know 20 students study history and 18 study geography. So within this history circle, we need 20, and within this geography circle, we need 18. Now this accounts for double ups. So the question is, well, how are we going to kind of know how much is in the middle to determine how much we're doubling up by? So recall that because of this 7, we need 34 students remaining. So the people in history and geography is equal to 20 plus 18, okay, which is 38, minus the students which we're supposed to have, which is 34, okay, and what that obtains is 4 students. Okay, so to make sense of this, what we've done is we've added the number of students in this history circle to the number of students in the geography circle, and in doing this, we've kind of added this middle section twice. Okay, and what we do is we subtract it by what it's supposed to be, which is 34, and that gives us that middle section. Okay, so this is 4. Now if this history, the whole circle is supposed to be 20, that leaves this to be 16, and if this geography circle needs to add up to 18, and 4 of these are taken within here, what's on the outside of that is 14. Okay, and we can verify that 16 plus 14 plus 4 plus 7 gets us, this should have been 33, and that should have been 5. That's my mistake. So that means we have 5 in the middle here, and we're going to have 15 here and 13 here. Sorry for that. And so find the probability that a student studies both history and geography. So the probability that they study history and geography is going to be equal to 5, because there's 5 students who do both, out of the total of 40. Okay, so 5 out of 40, which is just simply 1 in 8, if we simplify that. Okay, a student is chosen at random. Given that the student studies geography, what is the probability that the student does not study history? So we desire the probability that a student does not study history, so H bar, given that they study geography. Okay, and recall the definition. So the definition of conditional probability states this: if the probability of something given something else is the probability that they both happen, so the intersecting region, over the probability that this happens. Okay, so it's saying what's the probability that they are both happening. So what's the probability that a student does geography and doesn't do history over the probability of students doing geography? So what we can see is that the probability of the students doing both, so geography and not history. So all these people here do geography, 5 of these people do history, so not history is this 13. So that's going to be 13 over 40, all over the probability of someone doing geography. So how many students do geography? And that's 18. So that's going to be 18 over 40, which simplifies to 13 over 18. Okay. The final question of this says two different students are chosen at random, one after the other. What is the probability that the first student studies history and the second student does not study history? Okay. So what we got to consider here is, well, what's the probability that a student studies history first? And that is going to be 20 out of the 40. So that's going to be 20 out of the total 40 for the first student to be, for the first student to study history. And we're going to multiply this probability by the probability of the next student not studying history. So now we've picked one student, so now the total amount of students we have is over 39. And the question is, well, how many students now don't study history? And that's still this 13 plus 7, so that's still 20. So that's going to be 20 over 39. Okay? So it becomes 20 over 40 times 20 over 39. And that gets us, so 20 over 40 times 20 over 39 gets us 10 over 39. And that's our answer. Okay? This is question 15 here, which says, Mr. Ali, Miss Brown, and a group of students were camping at the site located at P. Okay, so at this site P, that's where they were camping, and this is where Mr. Ali is, and this is where Miss Brown is. Mr. Ali walked with some students on a bearing of 0.35 degrees for 7 k's to location A. Miss Brown, with the rest of the students, walked on a bearing of 100 degrees to location B. So what and then we need to find that the angle APB, so we need to show that that is 65 degrees. What we can see here is that the bearing of P to A is 35 degrees. So that's 35 degrees here. And the bearing from P to B is going to be 100 degrees. So this whole thing here, okay, that whole thing there is 100, which means angle APB is going to be 100 minus 35. So we say angle APB is equal to 100 degrees minus 35 degrees, which equals 65 degrees, which is what we needed. Now we need to find the distance AB. Now hopefully you can recognize that in order to find this distance, we're going to have to use the cosine rule. So by the cosine rule, okay, so if we use the cosine rule, AB squared, so that length squared, is equal to 7 squared plus 9 squared minus 2 lots of 7 times 9 times cos of the included angle, which we've just found to be 65 degrees. Okay, so then we get AB squared is equal to, so we get 49 plus 81 minus this thing here, which is going to be, so 2 times 7 times 9 times cos 65. That's approximately 53.25. And that means AB squared, if we just so cos 65. So when we put these all together, we get 76.75, and we take the square root of this, which is going to be 8.76 kilometers, and we're going to say that's the 2 decimal places. Okay. Sorry, I haven't shown the working here. So we did AB squared is A squared plus B squared, so 7 squared plus 9 squared, minus 2 lots of AB, so 7 times 9 times cos of the included angle, which is cos of 65. And basically we've just solved for that. Then the final question says, find the bearing of Miss Brown's group from Mr. Ali's group. So from Mr. Ali's group, what's the bearing to get to B? Okay. And so we need to consider a few things here. In order to find this bearing, it's going to be measured from north of A, and we need to go around a certain amount, okay? So the question is, well, what is that amount that we go over? And what you can hopefully recognize is that we can now find out what this whole angle is. And we're going to use the cosine rule for that. So, sorry, the sine rule. So we can say this angle, we can say sine of this angle over 9 is equal to sine of 65 degrees over what we found AB to be. So that's exactly what I'm going to do. I'm going to say sine of angle A over 9 is equal to sine of 65 degrees over 8.76. Now if I multiply both sides by 9, I get sine of A is equal to 9 lots of sine 65 degrees over 8.76, and I take the inverse of sine on both sides, so my angle is the inverse of sine of this. And if I just plop that in my calculator, I get that the angle is equal to about 68.61 degrees. Okay, so this whole angle is 61.61 degrees. So what I'm going to do is construct another bearing, and that's the south. Okay, so that's like the south direction, and by alternate angles I can say that this is 35 degrees. Okay, excuse the mess, I'll do a little arrow. So this little angle in here is 35 degrees by alternate angles. Okay, so that means 35 plus this angle over here needs to give me this 68.61. So I say the angle of SAB, so SAB, okay, that's going to be equal to 68.61 minus 35, okay, which is going to get me 33.61 degrees. Okay, now if that's 33.61, I know this whole thing's 180, so 180 minus 33.61 will get me the desired angle I need. So I say bearing equals 180 minus 33.61, which is 146.38 degrees. And now to the nearest degree, okay, because I need this answer to the nearest degree, that's going to be 146 degrees, and that's my bearing. Question 16. So question 16 says sketch the graph of the curve y equals negative x cubed plus 3x squared minus 1, labeling the stationary points and point of inflection. Do not determine the x-intercepts of the curve. Okay, so first I'm going to rewrite the equation y equals negative x cubed plus 3x squared minus 1, and I'm going to do my derivatives. So y dash is negative 3x squared plus 6x, and y double dash is negative 6x plus 6. Now to determine my stationary points, so I say stationary points, that's going to be at y dash is equal to 0, so when my derivative is equal to 0. And that's going to be negative 3x squared plus 6x equals 0. I factor out a negative 3x, and I obtain an x minus 2. So that means x is equal to 0, or x is equal to 2. Now I consider each point at x equals 0. Okay, so what happens when x is 0? So what's the y coordinate at x is 0? And that's going to be negative 0 cubed plus 3, 0 squared minus 1, which is going to get me minus 1. So therefore my point is 0, negative 1. Also, y double dash is equal to negative 6 outside of 0 plus 6, which is going to be 6, which is greater than 0. Therefore, it is a minimum at 0, 1. Okay? So we have a minimum at that point. Now we're going to consider the other stationary point, which was x equals 2. So at x equals 2, we need to find the y value. So the y value is y equals negative 2 cubed plus 3, 2 squared plus 1, which is equal to, that's going to be equal to 7. So we have the point 2, 7. And now we need to determine its nature. So we sub in 2 into the second derivative, and what we obtain is negative 6, which is less than 0. Therefore, maximum at 2, 7. Okay. Alright, now we need to determine the points of inflection. So that is when, so point of inflection when the second derivative is equal to 0. So therefore, we let negative 6x plus 6 be equal to 0. So negative 6x equals negative 6 and x equals 1. Okay. When x is 1, we need to find the y value. So negative 1 cubed plus 3 1 squared minus 1. And what we obtain is 1. So it's the point 1, 1. Okay, now this is a possible point of inflection. Remember that we need to test to see whether it is actually indeed a point of inflection. And how we do that is we construct a table, and we got to see that the second derivative at x values around this point changes. So if there's a change in concavity. So we're considering the x coordinate of 1, and then something a little bit after, which is 1.1, and a little bit before, which is 0.9. And obviously the concavity, what we found at 1 is 0. Now we sub in 1.1 into our second derivative. And what we get is negative 0.6. So it's a negative, we're 0. And now at this point, at 0.9, what I obtain is positive 0.6. So that's a positive. So therefore, due to a change in concavity, a point of inflection exists at 1, 1. Okay. Now we've got everything that we need to sketch this graph. So I'm going to draw my axes real quick, label them, the x and the y axes, and now I'm going to label my points. So recall, I have a minimum point. At 0, 1. Okay, so 0, 1, that's a minimum point here. So I'm going to say minimum 0, 1. Okay. I have a maximum at 2, 7 down here. So at 2, 7 I got a maximum. So I'm going to say that is about here. And I've got a point of inflection at 1, 1, and I'm going to draw that in a little bit later. So logically, you can probably infer that the graph is going to look something like that. Alright, and then I label point of inflection at 1, 1. And there we have it, that's our graph. Okay, so then we get to this page. Okay, so find the integral of this. So what we need to recognize is that this is almost going to be the derivative of what's on the bottom, which resembles closely to a logarithm. So what is the derivative, okay, of the bottom? And that is 2x. So I'm going to put a 2x on the top and keep my denominator the same. And now, because I've added an extra 2 in, I've got to kind of put a half out the front, dx, and that's going to be equal to a half outside of ln of 4 plus x squared, okay, by the definition. And now don't forget the plus c, because it's an indefinite integral. The next question says, differentiate this. So we're going to, hopefully you can identify that we're going to use the product rule. So I'm going to let u equal e to the 2x, u dash is 2e to the 2x, v is equal to 2x plus 1, and v dash is equal to 2. So that means the derivative, okay, of e to the 2x outside of 2x plus 1 is going to be equal to vu dash plus uv dash. So vu dash is going to be 2e to the 2x outside of 2x plus 1, okay, plus uv dash, which is going to be 2e to the 2x. And hopefully you can recognize that you can just factorize this quite easily with the 2e to the 2x. And that leaves me with 2x plus 1 plus 1, okay, which is going to be 2x plus 2. And what I can do is factor out the 2 from here and put it to the front. So it's going to be 4e to the 2x, x plus 1. Now the final question says, hence, find the integral of this. Okay? So how we're going to do this is we're going to need to use the previous part. And we found that if we derive this thing over here, we end up with this, which looks remarkably close to that. So let's say I did have this, which was 4e to the 2x outside of x plus 1 dx. What have I done to manipulate this? And I've multiplied it by 4. So to get it back to kind of like its original form, I need to divide by 4. And now, because I know the derivative of this gave me that, so if I integrate this, it will give me this function. So that means the integral is going to be equal to a quarter outside of e to the 2x, outside of 2x plus 1, plus your constant c. Okay. The second last question of this section states that we need to prove that sec theta minus cos theta is sine theta times tan theta. So how we do this, we start with the left-hand side and regurgitate what it is. Okay. Now we need to recall that sec theta is 1 on cos theta, and this is minus cos theta over 1, if you like. Now what I'm going to do is I'm going to combine these two fractions. And in order to do that, I need to make cos theta my common denominator. Okay, so I don't touch this fraction, but this fraction I need to multiply both sides by cos theta. And this will leave me with 1 minus cos squared theta over cos theta. Recall that 1 minus cos squared theta is sine squared theta over cos, and now that's all over cos theta. And look where we need to get to. We need a sine theta times a tan theta. Now we already have a sine theta there, so let's kind of bring it out. So it's sine theta times sine theta on cos theta. And what do we know about sine theta on cos theta? That's just equal to tan theta. So it's sine theta, tan theta. And there we go. That's it. Question 19. Question 20. The last question of booklet 1 in section 2. It says, Kenzo is driving his car along a road while his friend records the velocity of the car, v of t, in kilometers every minute over a 5-minute period. The table gives the velocity, vt, at time t hours. So we've got this table over here. The distance covered by the car over a 5-minute period is given by this integral here. Okay? Use the trapezoidal rule and the velocity of each and the velocity at each of the 6 time values to find the approximate distance in kilometers the car has traveled in the 5-minute period. Give your answer correct to 1 decimal place. So we need to use trapezoidal rule to approximate the distance, and recall that if we integrate velocity, we get displacement, which in this case is going to give us distance because we don't change direction. So I'm going to say the distance is approximately equal to, now I need to use my trapezoidal rule, and notice that, so the trapezoidal rule is going to be h on 2 outside of f of a plus f of b, where a and b is like your first and last terms, plus 2 lots of f of a plus h plus f of a plus 2h plus all the way up to b minus h. So this is basically saying the y value at a, the y value at b added together plus 2 lots of basically everything else. So this is going to be h on 2, and our h is 1 on 60 because that's how we're moving every time. So that's going to be 1 on 60 all over 2 outside of the first plus the last, which is going to be 60 plus 67. So I'll fill that in there. Plus 2 lots of everything else. So 2 lots of 55 plus 65 plus 68 plus 70. So 55 plus 65 plus 68 plus 70. And that gets us, so that's going to be 1 on 120, outside of 60 plus 67 is 127, plus 2 lots of everything in the middle, so 55 plus 65 plus 68 plus 70, and that gets us 258. And if we just put this all in the calculator, we obtain that the distance is approximately, what do we want? We want it to 1 decimal place. So what we get is 5.358, and to 1 decimal place, that's going to be 5.4 kilometers. 1 decimal place. And that's it. If you had any trouble with these questions, or if you misunderstood an explanation, let me know in the comments, and I'm more than happy to try to explain it a little bit better in the comment section. Other than that, I hope going through this has helped in your studies, and I wish you the best of luck for your future studies. Good luck.